Understanding ownership and lifetimes in Rust. Lesson 1. Memory management, starting with the stack. When you write a program, any program, you are using data. Variables, objects, function parameters. But have you ever stopped to ask, where does all of that data actually live while your program is running? It needs to be stored somewhere in the computer's memory. For most programming languages, memory is primarily divided into two key regions, the stack and the heap. These two regions serve very different purposes, and understanding how they work is fundamental to writing efficient and bug-free code. Today, our focus is entirely on the first one, the stack. So, what is the stack? The stack is a region of memory where your program stores data in a very specific, organized way. The most important concept to understand about the stack is its structure. It operates on a principle known as LIFO, which stands for last in, first out. The classic analogy is a stack of cafeteria plates. When you add a new plate, you place it on top of the stack. And another on top of that. This action, adding an item to the top, is called a push. Now, when you need to remove a plate, which one do you take? You take the one on top. The last one that was put in is the first one that comes out. This action is called a pop. The stack in memory works exactly the same way. It's a simple but incredibly powerful and efficient data structure. This LIFO structure gives the stack three distinct characteristics. First, it is fast. Allocating memory on the stack is as simple as moving a single pointer. There's no complex search for free space. It is, for all practical purposes, instant. Second, data on the stack must have a fixed size. Because the stack is so rigidly organized, the computer needs to know exactly how much space to reserve for each item before the program even runs. This is why things like integers, booleans, and other simple types are perfect for the stack. And third, as we just saw, it's LIFO. This last-in, first-out mechanism isn't just for organization. It's the key to how the stack automatically manages your program's memory. Let's see this in action with a simple piece of code. Here we have our main function. As soon as this function is called, it gets its own block of memory, called a stack frame, pushed onto the stack. Now we declare a variable, x, and assign it the value 5. Because x is a simple integer, its size is known. So, it gets pushed directly onto our function's stack frame. Next, we declare a boolean, y. Its size is also known, so y is pushed onto the stack right on top of x. Now, watch what happens when the function ends. The function's scope is over. The stack automatically cleans up. Because of LIFO, it pops the last item that was added, y, which is now gone. And then it pops the next item, x. And just like that, our stack is clean. This automatic allocation and deallocation is what makes the stack so efficient. There's no garbage collection needed for this data. It's all handled by the LIFO structure. This LIFO structure is also how your program manages function calls. Every time you call a function, a new stack frame is pushed onto the stack. When our program starts, the main function is called. A stack frame for main is pushed on. It contains its local variable a, which is 10. Now inside main, we call a new function, calculate. This call pauses the main function. A new stack frame for calculate is pushed onto the top of the stack. This new frame holds the parameter n, which receives the value 10, and its own local variable, result. At this moment, the calculate frame is at the top of the stack. It is the only function that is currently active.
Now the calculate function finishes its work and returns. Its stack frame is popped off of the stack, and all of its local variables, n and result, are instantly destroyed. Control returns right back to where we left off in the main function. Now main finishes. Its stack frame is popped, its variable a is destroyed, and the stack is empty. The program is over. This stack of frames is literally why it's called a stack call. So let's summarize. The stack is a highly organized, very fast region of memory used for data that has a fixed, known size. It uses a LIFO structure, which allows it to automatically manage memory. Data is popped off the stack when it goes out of scope. This makes it perfect for managing local variables and the flow of function calls. Understanding the stack is the first major step in mastering memory management. But what about data that doesn't have a fixed size? What about data you need to live longer than a single function? For that, we need to explore the other region of memory. In the next lesson, we'll explore the heap.